I trust that I don't need translations of myself. We'll see. My wife would probably disagree with that. Okay, so a little bit of a philosophical question. Why are we here today? Why we're here today? Memory of energy, right? Using it a little broadly, electricity, right? Energy. How can we make progress on such a broad issue, right? We've heard all kinds of amazing ideas and initiatives, legal constraints and issues. My argument would be we make progress by focusing, right? We need to kind of focus our energies. Focusing on what? Energy. And so I'm going to suggest that we sort of, at least for the next few minutes, shift from memory of energy to energy of memory. Thinking about the fact that digital preservation is essentially a set of decisions about investment of resources, energy, human attention, all kinds of things that are very limited. And so we have to make a lot of decisions about how we're going to actually invest those things. I would contend that essentially we have this relationship between the complexity of an idea, of an expression, and the difference of context, so that if you're down in the bottom left corner of, my apologies for the tiny picture, but if you're in the bottom left corner, that's the easy spot. That's a married couple in the morning planning their day, talking about, who's going to pick up something from the grocery store. It's a lot of grunts and incomplete sentences, and because there's a great deal of common ground, right? You have a lot of commonality of context, and the ideas are very simple. The top right corner, we're probably, a guy speaking in English in Brazil about digital preservation is probably a little bit farther up in the corner. But things that involve difference of perspective, difference of technical platform, those are always expensive in the sense that I'm talking about. Use of energy, whether that's human attention, whether it's money, whether it's computational resources. So, if we have a simple ASCII text file, something that's just plain text, that's very, very simple to move from one computer platform to another. But if you have some deeply complex scientific data set that was generated from lab equipment that was built for that lab, moving the data in a meaningful way to some other context is very expensive in the way that I'm talking about it. And so we can sort of play this game where you can adjust along one of these dimensions. If you want to make things more simple, you can insist on more similarity of context. You can only download this application on a particular operating system. My app only works on this platform or something, right? So you reduce the contexts, or you can reduce the complexity of the thing itself. So you can normalize, we were hearing earlier about CSV files, for example. You can take data out of a database, reduce it to CSV, where it's just text with commas in between. That's much more simple, so it's easier to move across systems, but you've reduced a lot of the internal complexity and meaning to the information itself. So how then to focus? How can we focus our energies sorry if I'm overusing the metaphor, but here we go. Well, there are fundamental archival principles that are very much how I come to this. I was trained as an archivist. I've worked in the archival profession for about 20 years now, I guess. One thing is provenance, so this is making sure that we can reflect where things have come from, who created them, what was the purpose, what was the set of activities that generated the materials, the records, as archivists would talk about them, but obviously in a wider set of GLAM institutions, we refer to them as artifacts and different things. The original order, so this idea that often what we want to be focusing on is the information that provides the context so that you know how things were arranged with each other. A very traditional example of this, traditional in the electronic records world anyway, is email. So if you have an email message and an attachment, you want to make sure that the association between those two is maintained. And then also chain of custody, making sure that we know what has happened. Premise metadata, for example, it's a metadata standard for digital preservation that allows you to document the events that have happened in the life of the materials. So this is part of how we help to focus our energy, is to think about what is it that we really need to be capturing. But what is different about digital materials? You might have seen in my title that it talks about representation, right? Different levels of representation. There are a variety of levels of representation in digital information that makes them different from analog materials, right? So if you're looking at a photograph, If you're reading a printed page on paper, you might have to squint, right? But essentially, it's unmediated. You're just looking at the object. With digital information, it resides at many different levels at the exact same time. And so there's a lot of decision making that is involved in determining which of those levels we're focusing on. What is the it? What is the thing that we're actually trying to preserve? And how should we try to provide access to it? So I'm going to briefly go through each of these levels to then motivate some of the methods and principles that I'm going to talk about. So the first is aggregations of objects. So archivists often talk about things like phone, record groups, series, depending on what country you're in, series in a library context of things that have been published in a set that are associated with each other. And many people in GLAM institutions spend a lot of their time focusing on aggregates. You're actually looking at the thing that defines the relationships and not just the objects themselves. But stepping down from that, there's this level called an object or a package that's really fundamental to digital preservation. We heard yesterday, well, we've heard about it both days, but in most detail about the OAIS reference model that has this idea of well, in English, they are SIP, DIP, AIP. And the submission information package goes in, the archival information package is what's retained, the dissemination information package is what goes to the consumer, the people who are using the materials. All three of those have this idea of a package. So it's not just like the ones and zeros that make up a file, it's a lot of other metadata that goes with it too. Or you can think, for example, of a web page. So a web page has many different components to it. It can have a style sheet and images and all kinds of things that are embedded together. It's not just, for example, an HTML file. So if you care about it as a coherent whole, you would actually want to think about it as an object. But let's say that it was a page of images like we saw earlier today. You might only want to pull the pictures out. You don't care about how they appeared within a page, you just want to pull the images out. And so in that case, you wouldn't be looking at the whole object, you'd be looking at the component parts. There's the in-application rendering, which is how it actually appears in a particular software environment. Focusing too much on this has a phrase associated with it in the digital humanities field. It's been called screen essentialism. And the idea is that you think that the digital object is just what you see on the screen. And I'm going to be talking a bit about the application of digital forensics to GLAM institutions, and a lot of the motivation for that is to recognize the danger of screen essentialism, of thinking, well, I mean, I saw what was on the screen, that must be what the object is, because there's a lot of other information associated with digital objects. There's the file through the file system. So the file system is the place on your computer that associates the name of the file, untitled.doc is the most popular one in the US anyway, the path, so what structure it was in, what files and folders are associated with it, and also things like timestamps. So those become very important to know when something was modified, accessed, changed, or created. Also access permissions. So if I were to share a file with you by throwing it onto a website and you were to download it, you would get the file, but you wouldn't get all of that metadata that was sitting on my file system. And if those were my personal papers that I were donating to an archive, that might be very problematic, that you don't get all of that contextual information that's embedded in it. So making that distinction between, do I want the file, or do I want this higher level of abstraction that involves all of this metadata along with it? There is the file as a raw bit stream. So digital data is ones and zeros at some level. And you can look at them in what's called a hex editor and see the component parts of a file. There's the subfile data structure, and I'll be showing some examples of each of these, and I hope that they're not too small on the screen. You'll be able to follow with them. I'll point them out as we go along. So the subfile data structure is anything that's below the level of a whole file, but is important to be thinking about as the object that we want to preserve. There's the bit stream through the input-output equipment. So think of the very evocative image that we saw yesterday of the box full of all the obsolete drives, right? So what are you going to do with these floppy disks and USB flash drives and all these sort of things? Well, A step that many GLAM institutions are taking now is creating what's called a disk image. And the idea is you attach the drive to your computer with a device in between that blocks the path of data to the disk so it only comes into your machine, and you copy every sector off the drive. You basically replicate the disk rather than just copying the files off. And this is something that's done in forensics, so for law enforcement, quite widely, but it's also being used in a lot of cultural institutions. Even below that level, when people talk about digital information, there is a tendency to say they're made up of ones and zeros, as if somehow at some moment in human history, God came down and said, that'll be one and that'll be zero, right? The reality is that even at that very, very low level, it's just a bunch of human decisions. Somebody decided to orchestrate equipment so that it reads that voltage level to be interpreted as the number one versus the number zero, right? And so you can actually capture the raw signal stream off a disk that is telling you what the magnetic pulses were coming off the drive before they were interpreted as ones and zeros by the equipment. So there's something called a cryoflux that many libraries, archives, museums are using for this purpose. And then finally, there's the physical thing, right? There's always some physicality to digital materials. Even if we're in cloud environments where things are very distributed, ultimately they're stored somewhere, right? And there's a lot of discussion about the environmental impact of that now as well. So just a few examples of what I'm talking about. This is an aggregation of objects. This example comes from New Zealand, where they have these gazettes. So they're these publications that the National Library is responsible for. And at one level, they'll probably want to reflect the organization. What issue was this part of? What other documents was it associated with? Right? But they could also then want to see something as a whole package where it has the file, you know, there's a PDF file you could download, but it has this other information, this other metadata along with it. There's the in-application rendering, where you can see how it would look if you opened it in Acrobat or some other program. There's then the file through the file system, so you can use a command line or you can use a graphic user interface to see the information about the file, not just the file itself, but things like, again, timestamps, permissions, and things like that. So the file system, again, is this essential layer that has all of these things associated with it. Access controls, timestamps, the size of the file, where things are stored, that can be very important to capture. This is a hex editor. Who here has used a hex editor before? Not too many? So a hex editor is used to look inside of data to actually see what the bytes are. And I promise not to use too much math. Except to point out the reason it's hexadecimal, which is 16 possible values, which seems like a very odd number to pick, it's because that exactly matches the ability to replicate a byte, which is 8 bits, which is used a lot on computers, as 2 different characters. So you see there it's 255044. These are the kinds of techniques that are very, very useful in digital preservation scenarios when things get problematic. If there's a file that you can't read, if it's corrupted, if it's not well documented, this is a way to not try to look at it on the screen in an application, but to go inside of it and see what's actually the component parts of the file. Anyone recognize this? Might be too far away. So this is it's a zip file. Right? You've probably seen zip files before. It's a particular kind of zip file that you might have used many times yourself. DocX, PPTX, XLSX, those extensions, right? Microsoft Office files are all zip files. The same is true of ODF, so if you use LibreOffice, OpenOffice, they create those pages on a Macintosh, which is another word processing program. There are many contemporary formats that are just a zip file, but with a different extension so your computer knows how to open it with something else. And so if you go inside of this zip file, you can see the component elements of the Word document because they're all broken down into these little folders. This is just another example of subfile data structures. This is EXIF metadata. If you've never looked at the EXIF metadata inside of a picture that you've taken on a phone, for example, it can be very revealing. It says where the picture was taken, if you have geolocation turned on your phone. It says where it was stored, how big the file is, when it was modified, whether you used a flash. All this kind of information is embedded in the file and carried around with it with some exceptions. If you upload it to Facebook, Facebook strips all of this out. This is another example. This is a feature that was in Microsoft Word for many years called Fast Save. And essentially, in order to make the performance faster, it would not make a full change to the file. It would instead mark it as needing to be changed using what was called Fast Save. So if you know this, you can go in with our friend, the hex editor we were just talking about, and see information inside of the file that reflects how it had been revised over time. So this is an example from Jonathan Larson, who created the musical Rent. He died quite tragically pretty early in his life. And so an investigation with these kind of tools showed lyrics from a song from his musical that hadn't been known previously. So this is a piece of software called Geimager running in the Bit Curator environment. I'm going to talk a little bit about the Bit Curator environment in a few minutes. It's free and open source software that allows you to apply digital forensics methods. And this is creating a disk image. So it's going to a disk and copying all the sectors off of the disk. This is the device that I called the CryoFlux. I called it that because that's what it's called. It wasn't a very creative act. Some would say it was an exact copy and thus maybe not copyrightable. The information on the right there is showing the actual electrical charges coming off of the device, and then you can see how they're being interpreted as ones and zeros. This sounds a bit space-agey, but it's used in a lot of cultural institutions when they have older floppy disks that are problematic because they're encoded in a way that the drive isn't recognizing. So it's a way to recover data. This is another. Did anybody ever use audio cassettes to store computer data? So back in the earlier days of computing, people would, for example, maybe have a personal computer, a Commodore 64, for example, and they could have either had a floppy drive or a tape drive, right? So if you want to get the data off of that tape, you first have to make all the squeaks come out, right? You have to make it generate noise, and then you have to interpret that raw signal stream as a set of ones and zeros. So it has to go from something that's an analog signal, it's waves in the air, to something that can actually be broken down as to ones and zeros. And then finally, if you don't recognize this, this is the surface of a hard drive, magnified very, very intensely. So you can see the actual arrangement of the particles on the surface of the drive. But there are three complicating factors here: medium failure, bit rot, obsolescence, and volatility. So bit rot is this idea that ultimately, that box of disks that we saw, I think you gave the scenario of like 60 years from now or something, right? So that, I mean, if it's 5 years from now, you can just use adapters and things, right? Eventually, the data is not going to be readable because it becomes unreadable. It has the same kind of inherent vice that analog materials have. It breaks down. And it also becomes impractical to use older drives because they're so inefficient. They're they're not compact, right? So you can store a terabyte of data on a laptop very easily. A terabyte of data on floppy disks would fill this entire building, right? So you don't do that. Obsolescence is the idea that eventually the technology that you need to read or write the data goes away. It's not supported by the industry anymore. And then finally, order of volatility is this fact that information changes at different rates on a computer. So an example that comes from forensics is if somebody were to give you their computer and say, you can now find out what this person's habits were, what they were doing on the computer, or what they were doing with their web browser, if you opened up their web browser and started clicking around, you'd be overwriting a file that's called the cache that keeps copies of recently viewed pages. And so if you cared about reflecting that, you would want to make sure that first you capture that information. So there's this idea that basically by observing the data, you're changing it, and you want to make sure that you can capture things in a way that don't inadvertently change them. Another thing that's being used in a lot of GLAM institutions now is write blocking. I mentioned this briefly before, and the idea is just using equipment so that if you hook up a device to your computer, you don't accidentally write to that drive and change it irreparably. You can only read the data off. And so here are just some examples of that. These are hardware-based write blockers, so equipment that you can use to basically plug devices in. This is the kind of capabilities that are built into some of the media, like the older disks, right? So the 5 1/4 inch floppy If light can get through, it's not write protected, so you can see the little notch. In a 3.5-inch disc, the stiffer one with the little sliding window, if light can get through, it is write protected, so you open up that little notch. And in the bit curator environment that, again, I'm going to talk about in just a few minutes here, it has this capability to sort of say, if I'm going to attach a device, I want to make sure that it's not going to write to it, I'm only going to read from it. That's based on software. It's not as guaranteed as using hardware, so a lot of institutions use both. So all of this suggests that it might be useful to use digital forensics methods, things that are traditionally used in law enforcement, for GLAM institutions, so that we can solve a lot of the same problems that they've already addressed many years ago. So one is use of write blockers, I already mentioned. Another is generation of disk images, applying cryptographic hashes, so basically having these calculations that show whether a file has changed. Capture of what's called DFXML, so the metadata that's used by a number of these tools. I'll show that in a few minutes. And scanning bit streams for personally identifying information. That's one of the things that's been very fruitful in this space, is basically taking tools that are intended to find things that people tried to hide, to find things people accidentally left there, right? So if your personally identifiable information is on a disk and you donate your materials to an archive, you don't necessarily want every little bit of that information to be disclosed to the public, or maybe even put into the archive in the first place. But there is need for adaptation of digital forensics to cultural institutions, because we have different priorities. We care a lot more about metadata, making sure it's consistent, mappable, interoperable, a lot of the things we've already heard about at this conference. Provisions for providing public access to the data, that's not something that forensics as a field cares about, because they're just using it in a very limited context. And also support for older technologies. I've already mentioned floppy disks, which archives and libraries and museums are dealing with quite a bit more now. But also things like older file systems. So the Apple operating system, right, the Mac operating system, one of Apple's operating systems, had its file system called HFS. Then it was HFS Plus, now it's called APFS. So the industry moves toward whatever people are using now, because they need to extract the information that is on current computers. But in cultural institutions, we have to go back farther, because those media have a lot of important information on them. This is a report that came out of the Bit Curator project. It's available online, talking about this application of these ideas. This is just to give you an idea of one possible setup. This is at our school, so we have a couple of these things called FREDs, which are these forensic machines, and lots of adapters and devices and things, right? That we're not a library or an archive, we're a school, so we use this for teaching and research and that sort of thing. So students can come in and work on projects by using all this equipment. So we had a project called Bit Curator. It was funded by the Andrew W. Mellon Foundation, which is a private foundation in the US. And it ran from 2011 to 2014. It was a partnership between our school, where I am at the University of North Carolina, and the Maryland Institute for Technology and the Humanities, which is at the University of Maryland, which isn't too far from us. And the goals were basically to take a lot of free and open source digital forensic software and make it usable for GLAM institutions. And so that's what we've done. And try to adapt it in various ways that are more useful to the workflows that people in cultural institutions need. We also, in the second phase of the project, generated a report that was more about the community engagement aspects of the work. So the Bit Curator environment itself is, again, it's all free and open source software. It's a Linux operating system. It's specifically an Ubuntu Linux operating system that we have adapted in a variety of ways to configure with different scripts and different software installed, and it supports a workflow of activities that people engage in when they're processing digital materials for libraries, for archives, for museums. It can be run just as the operating system for the computer itself. So it's a Linux operating system, so your computer can just run Linux. It can be run as a virtual machine inside of Windows or Mac operating systems. And it can also be run as its different component parts if you don't want to run the whole environment, if there are just some parts of it that you want to use. And people generally get started by using what's called the Quick Start Guide, which is available also on the website, on GitHub. There's a consortium of, I believe the latest count is 43 institutions. It is an international consortium. There are 4 countries represented, none in South America so far. It's a continuing home for hosting, stewardship, and support of this software, right? So if you heard me say, I'm a professor and I got a research grant to develop software several years ago, you should probably be pretty skeptical about that software. But the software is maintained and perpetuated in the community around it by this consortium, right? So it's not just us as the researchers continuing to maintain it. And this is just happy users of the software. People are always happy when they use the software. This is the set of tasks that people, it's amazing, no other software does that. Acquisition, reporting, redaction, and metadata export. So this is to put in context that what I'm talking about is a set of tasks that are different from, for example, Archivomatica, which we've heard about several times at this conference, which is a digital preservation environment. It's different from, say, Atom that is used for archival description. It's really for this kind of triage, early processing, characterization, and review, which was a spot in these various workflows that had essentially kind of been missing for a lot of institutions until the introduction of the software. So this is the main acquisition interface for Geimager, again, creating a disk image in this environment. Once you have a disk image, you can either mount it, so you use built-in software that allows you to just make it look like it's now attached to your computer, even though it's just a file, because a disk image interacts with your computer just like a disk does. Or you can forensically investigate it with another tool in this environment where you can look inside and see what files are there. The ones that are red are deleted. So in a FAT file system, which stands for File Allocation Table, if you delete a file from a directory, that directory entry stays forever until that drive gets reformatted, but it gets appended with a little character sequence, E5 and hex, that makes it invisible to the end user. But you can use forensic tools to see whether there's information left behind that people had deleted, right? So obviously this raises all kinds of questions in terms of when this is appropriate to do and when it's absolutely necessary to do, because you feel that otherwise there might be information that could get disclosed that shouldn't be. This is a tool called Bulk Extractor. It was developed by someone named Simpson Garfinkel, and it is a very efficient, I can speak all the praises of it because it's not software that we developed. It very, very quickly searches for potentially sensitive information, geolocation information, a variety of identifiers like phone numbers and credit card numbers, dates of birth, things like that, and then reports them to you so you can see what might be there. This is a representation of the, so you see up here the reports that it's generated. This is an email histogram, so it's showing all the, it just searched through an entire disk and found anything that looked like an email address to it. And then this is the specific instance where you can see where that particular email address appeared. There's also exporting of what I had referred to earlier as DF-XML. So it's information embedded in the file system that tells you things like when the file was created or modified, or how big the file was and things like that. So this metadata that comes out of the tools explains what it has done. So it gives you a breakdown of what the steps were that it's followed. It gives you technical information about what the disk is, what sectors it has, and things like that. And then most of the metadata, really, this is not going to be an endless stream of XML, trust me. Just a little bit of XML. This is the output, and all of this essentially is telling you things that were in the file system. What were the timestamps? What is the name of the file? What kind of file is it? And that information then gets exported. And there's a schema for this that you can consult if you're interested in what all those different elements mean. There are also premise event snippets that are created. So again, premise is a preservation metadata standard, and if you're not familiar with it, one of its defining features is this idea of events. It's not just something that's bibliographic, it's not just explaining what an object is, it's also telling you about a process. It's saying, I converted this file, I transferred it to here, I reviewed it for personally identifiable information, or whatever it is. And so in the BitCurator environment, when the tools run, they generate these little premise event records. And various other specialized reports, things like what kinds of files were on the disk. It's helpful for when people are doing processing to see, oh, this was mostly PDF files, but a couple of spreadsheets or whatever it might be. So incorporating these digital forensics methods into GLAM workflows, this is the overall idea of the process, which is basically you've got something on a disk, you create a disk image, so you use a write blocker and you pull the data off, then it goes into this container format, a forensic disk image, and then you extract various kinds of information from it, right? Sounds pretty simple, not very many steps there. And just as a reminder, these are the parts of that process that the BitCurator environment itself supports. The BitCurator Consortium has a number of workflow examples, so different member institutions have reported on what their workflows are. We had a project called OSS ArcFlow, so that stands for Open Source Software Archival Workflows, and we had 12 different partners. It was a pretty diverse set of partners, but all from the US. We were funded by a US agency. But if you go into these examples, and these are all on the website here, you see these very, very wide PDF files that show the steps that these different institutions go through when they process the materials. And at the top, you can see the software. So we were focusing in this project specifically on them building workflows around Archive-O-Matica, ArchiveSpace, and the BitCurator environment. So 3 different open source platforms that are used for different parts of the process. And so if you see a dot at the top, that means that that was a piece of software that was used for that step. And then at the bottom, you've got the people part, so who played the role in carrying out that task. And then across the middle, you have the actual steps. And actually, Peter McKinney at the National Library of New Zealand has adapted this. This is what they're using for their workflows, but they've added in some extra lines for policies and metadata and things. But these can be useful to get an idea about how people are actually taking these steps in different institutions. We then had a project called BitCurator Access. The idea was that we wanted to support use, and just creating copies of data from disks is, I mean, that's a good first step to make sure the data is safe, but it's not actually providing any access. And so we went back to the Mellon Foundation, and they very generously funded us again, to support use of the materials by doing things like creating software that allows you to navigate through the contents of a disk in a web browser, redaction, so the idea of striking out things that are sensitive that shouldn't be disclosed. And we also worked with the team from the University of Freiburg that had developed emulation as a service. So Freiburg in Germany, they've now spun it off as a separate company, but it was developed in the university there. And so one of the things we developed is this redaction tool that allows you to scrub, fill, or fuzz. So it means that if you have a pattern on a disk and you want to give that disk image to somebody, but you don't want that pattern that might be sensitive, you know, a geolocation or a government identifier number or something, you can scrub it, which just zeroes it out. You can fill, where you say, I want to use this pattern to say hello, 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 whatever it is, right, and it'll replace it. Or you can fuzz, and that's specifically when you want to distribute a disk that has software on it that you don't have a license to distribute. So let's say I have the entire disk from your, say, Windows computer or a Mac computer, and I want to disseminate it to somebody. Well, I don't have permission to disseminate all the software on that disk. So if you use this fuzz functionality, it goes into all the executable files and messes them up. It breaks them so that they can't run, but then all the data files are still there. Emulation can be used for a couple different, so we heard about emulation yesterday, talking about, you know, emulation, migration, encapsulation, the different options. I think that was yesterday, wasn't it? Emulation as a service provides this platform for you to build emulators when you need them. And there are 2 different scenarios in digital preservation where emulation can be very useful. One is the just straight up emulation. You're just using that old object in the old platform so you don't have to make any changes to it, right? So you've got a file that was created on this old Mac computer, so you bring up what's essentially an old Mac computer and you open the file. Another thing is to use emulation for migration. So let's say you've got that file, you know that your current software can't support that format, but you know that software from 10 years ago not only supports that format, but can convert it to a format that you can read. So you bring up an emulator and then you do the migration within that emulated platform. So BitCreator NLP was again funded by the Andrew W. Mellon Foundation, and it was the project that followed off of BitCreator Access, and this was applying natural language processing. So the idea was to allow people to do things like identify names of people and places and organizations within the materials rather than just doing full text search over them. So one of the challenges of the kinds of materials that GLAM institutions tend to deal with is that they're very heterogeneous, and we've been hearing about that already at the conference. Natural language processing, which is a set of methods to treat text as text and not just a big string of characters, to really know, oh, that's a verb and that's a noun, and I can treat that as a common example from the US is Bush, the former president, versus Bush, the plant, right? And so if you want to distinguish those two, you can use software that's aware of not just that sequence of letters, but knowing what kind of word it is. NLP can get very, very effective, for example, in the private sector when you're using something in a company and you have a very, very specific use case where people are always going to be doing the same kind of task with the same kind of materials. But archival materials, library materials, museum materials often are very, very heterogeneous so that it's hard to really tune the software so that it's always going to be very accurate. So dealing with essentially good enough kind of values can often be helpful. So these are the steps that the software follows. First, you have to deal with a disk if it's on a disk. You have to extract the text out so that it can now be dealt with as natural language processing material. And then this is showing topic modeling, which I'll display just briefly. And then there's also a tool called Spacey that does named entity recognition. So named entity recognition is identifying names of types of entities like people, places, organizations. So BitCreator Access Web Tools is one of the things that we developed from these projects. And the idea is that you can search over and navigate through data from disks by just loading them up in a web browser. So somebody who is using the materials doesn't have to have all kinds of specialized software, they just need to have a browser. So this is what it looks like. You can go into different disks, you can see the disks there, and then you can navigate down into the disks and look at the content. This is on the fly extracting text from the file. And then something that we also incorporated into the software is named entity recognition. So if you bring up a file, it'll tell you things like what are the names of the people and the places and the nations and things like that. So this is where you can get the software. This is Gentim, which is topic modeling. If you're not familiar with topic modeling, it's basically a bunch of math. And it's math that tries to find correlations between terms without really knowing what they mean. So the idea is that if you have documents that have words that they share in common, those documents might be somehow related in a way that you're not quite sure why or how, right? And so topic modeling can really help to make sense of and to separate out and to process materials because it can tell you, oh, these all seem to be clustered into an area that, you know, think of materials from somebody who has their personal life and their work life both represented in the same materials. You might want to try to figure out how to separate those out. Tools like this can really help with that. BitCreator EDU is a project that we have going on now that's working with other schools to help them to incorporate a lot of these tools into their educational offerings. And I'm happy to answer more questions about that if people have them. And these are, again, this is very US-centric, right? This was funded by that same agency, the Institute for Museum and Library Services, an agency in the US. So once again, fairly diverse in terms of types of schools, but not diverse internationally. It's all US institutions. We also developed a PDF redaction tool. So this is different from, for example, Acrobat that you can use to do redaction of PDF in one way that it's free and open source software, right? Because nothing we've created is proprietary, so you can download it and do whatever you want with it. But the other is that it has this very useful handoff between the tools I just talked about and the redaction functionality. So if you ran that bulk extractor that I mentioned that might have found things like email addresses and phone numbers and things that might be sensitive, you can take the output from that bulk extractor and feed it into this tool. And then what the end user can do is go through and say, ignore this one, redact that one, skip this one, and then generate a redacted PDF file. So that's what the software is doing here. And then finally, what I wanted to wrap up with is the project that, well, a couple of these things are ongoing, but RATOM is our primary Andrew W. Mellon funded project again. They've been very generous to us in our work. RATOM stands for Review, Appraisal, and Triage of Mail. And appraisal and selection, figuring out which things should be preserved over time, is a set of functions that if you read the archival literature, right, the literature of the archival profession, there have been arguments going back decades that it's the most important thing that archivists do, deciding what should be kept and intellectually figuring out what should be the scope of our collections. And yet there's very, very little software support for it. And so we're trying to make one little step, at least in our project, to address that to some degree. Why would we be focusing on email? Well, because there's lots of it. We all know various social media and various mechanisms, just simple texts, you know, on phones and everything that people are doing. But even though we now have this massive diversity of ways to communicate, email still plays this really important role in terms of organizations. And, you know, it seems like practically every day, almost every country has some news story about some email being leaked or something getting disclosed, right? I mean, it plays a really important role in evidence. And the reason for RATOM, which seems like an odd name, is that Ray Tomlinson invented email, so it's a little attribution to Ray, RATOM, funded again by the Mellon Foundation, and our partnership is between our school at the University of North Carolina and the state archives. So, you know, each state in the U.S. has its own archives, and the capital of North Carolina is Raleigh, which is not very far from Chapel Hill. And so we're collaborating with the state archives because they did a project previously called Tomes that was working on software specifically for state government archives for dealing with email. These are the personnel. So myself, Cam Woods, who's the technical lead, Antoine de Torsay, who is the, well, I could even use the pointer. Antoine de Torsay, who's the software developer. Anusha Suresh is our project manager. And then, oh, sorry, I left someone off. Sangeeta Desai is the third person who should appear there at the State Archive. She got hired recently onto the project as well. So Camille Tyndall-Watson and Jamie Patrick Burns. So the tools that we've been developing, basically LibRATOM, which is for doing things like very high performance extraction of information from PST files. So if you use Microsoft Outlook, you have these, they're moving away from this, but there are still a lot of PST files. At least in the US, these are what are generally used, like if one company sues another company and they say, give us all this evidence, they send them PST files. And so we've been doing a lot of work to very efficiently pull out information, identify what the entities are, you know, how many messages and attachments and things, but also what are the names of the people and the places and all those things that appear. We've got these notebooks. If you're not familiar with Jupyter notebooks, this is a way of helping people understand what software does. It basically creates a web page that's also a program. And it has these cells where you can follow along and see what the snippets of code are doing. And so you can run the software from within this web page. So we've been developing those to be able to, and I can't claim, I mean, Jupyter is used very widely by a lot of people. We didn't develop it, but we're taking advantage of it, which can be very, very helpful for people to understand what the software is doing. And then also converting from PST or MBOX to e-access, which is this convention that was established in previous projects for metadata around email. So this is where you can find more information about RATOM. So my conclusions are essentially digital information is fundamentally different from analog information. And you know, I hope that you found that kind of set of levels of representation somewhat intuitive and useful to be thinking about the sorts of decisions that we have to make with digital information. They are different decisions from the already existing ones we have when it comes to analog materials, when it comes to paper and photographs and even electronic analog like, say, videotapes, right? And it resides at multiple levels of representation. Digital curation, so the care of the materials over time, requires identifying which representations to be able to reproduce over time. And then software, much of it free and open source. All the software that I've been telling you that we've developed through our team is free and open source, and you're welcome to use it and adapt it and tell us how it goes for you. Can help us to manage the most precious forms of energy, which are human attention and understanding, right? If we go back to that diagram where I was saying if you go to the top right corner, things get harder because you're going across different contexts, you're trying to convey meaning over time. The human attention is one of the most valuable aspects of that process, and the degree that we can use software to reduce the amount of human attention that's needed to just review things like where are all the personal names in this file or something, right? That's something that software has gotten quite good at doing, and luckily a lot of that software is free, right? So it doesn't mean free in the sense that it costs you nothing to try to adapt it, because it always costs resources to try to use software. But it means that we have this possibility of making use of it and adapting things that were developed for very different purposes to be used in GLAM settings or others. So thank you very much for your time, and here's where you can find out more information about that whole set of BitCurator related projects I was talking about. If you go to GitHub, and then the RayTom project, which is, again, the email focus project, is at the website indicated there. So thank you very much.
Oh, yeah, yeah. Oh, it's here. Vamos dar início, então, às perguntas novamente. Lembrando que perguntas podem ser feitas também através do Facebook, para quem nos assiste no momento. Perguntas, por gentileza? Senhoras, senhores? Nenhuma pergunta ou alguma observação? Sim? Peço que seja em português. Sim.
Não, eu até brinquei com o Carl, disse, Carl, vai fundo e fala tudo que você tem que falar, porque acho que vai sair fumaça do cérebro, né? Fumacinha. Eu fiquei bem contente, porque acho que, eu até comentei que muitas vezes é bom a gente ver apresentações onde que a gente não entende muito do que está sendo passado, porque a gente sabe que a gente tem muita coisa para aprender. E eu senti muito isso hoje. Acho que tem muita coisa que a gente tem, no Brasil principalmente, né, de aprofundar essa... É mais um comentário, né, Carl, do que uma pergunta, mas a gente tem muita área de pesquisa e desenvolvimento para crescer em termos de entender o objeto digital, né? E acho que foi muito interessante ver esses níveis de representação e de ver todas as possibilidades de software a pesquisar isso. Então, acho que espero que em breve a gente possa ter mais relação de usar isso é uma fala para todo mundo que está aqui, que representa instituições, a gente se engajar um pouco mais com esses projetos e trazer um pouco mais para as instituições de memória no Brasil essas questões que tem mais a ver com a tecnologia mesmo, né? Então, acho que obrigado pela fala, foi muito importante para a gente ter escutado.
Okay, well, thank you. And I will say that, I already know what I'm saying. I think that when I got involved in digital preservation about 20 years ago, that's around when I started really getting professionally involved in all of this, it was a very different landscape. Many of the fundamental questions, I think, weren't even formulated, and there was very little software support to do many of the things. So I think part of the really good news is that there's a pretty mature international community around digital preservation now, and there are a lot of tools, right? So we heard earlier, I'm sorry, I can't recall who had said it, about how, you know, very little of the work is actually the technology. So much of it is about, you know, the economics, the institutional change, people's behaviors, all kinds of things. And so the challenge is really making the decisions about what to do rather than whether there's technology to do it, because there has been a lot of, it doesn't mean we don't have very far to go and a lot of tools that still need to be built, but there's a lot more capability to do many of the tasks than there was when I started getting involved in this first professionally a couple decades ago.
A minha pergunta se refere a como é que nós podemos recuperar ou, de alguma forma, evitar que a obsolescência de alguns datas ou devices prejudiquem e de que forma nós poderíamos ressuscitar isso. Por exemplo, hoje em dia não é difícil você achar uma leitora de CD-ROM, mas uma leitora de cartão perfurado ou uma leitora de uma fita magnética de um computador dos anos 70 é uma missão um pouco difícil. Então, assim, considerando a sua excelente apresentação, o que pode... existe algum projeto em termos internacionais, coisa de gênero, que tenha a preocupação de fazer o enfrentamento de como é que a gente recupera valor, informações digitais que se perderam no tempo porque o device, a leitora de cartão perfurado, a leitora de fita magnética passaram a não serem mais fabricados ou passaram a ter a quantidade delas que existem passaram a se tornar em número muito reduzido.
Right, yeah, so that's a really excellent question and a fundamental one that many institutions have been looking at. So the British Library in the UK has done a lot. They were one of the initial institutions to be applying digital forensics, for example, to try to deal with things that are on various disks. The National Library of Australia has established a fairly large collection of media and created something called Mediapedia, which is a database of information about different media. There's no magic solution in the sense that there's hardware involved, so you need some way to hook things up. But there are adapters. A lot of it is focused on hobbyists, so a lot of the technology that you can buy to, for example, adapt from an old floppy disk to a USB port, so you can plug it into a current computer. Their primary market is people who are trying to preserve games, just enthusiasts who are nostalgic about old games. Some institutions, so Metro, for example, which is in New York City, is a service provider so that if you have things on old media, you can bring them in and use their equipment, right? If you say, well, I don't have one of those old drives, you can go in and basically use their facilities to read the data off of the old drives. There's a certain window where we have to figure out the adaptability. Can I somehow connect it? There's a point beyond that window when it probably isn't going to be necessary because the data is not readable anyway, right? So if you had paper tape is an interesting example, or punch cards, because they last much longer, right? And a number of social science data repositories have dealt with punch cards, right? So there are a variety of documented projects about getting data off of punch cards, right? But if you have, let's say, an 8-inch floppy disk, those big, huge floppy disks, there's a very good chance that even if you can find an adapter and hook it up to your computer, none of the data is readable anyway because it's so old that it's probably all decayed. So we kind of have this window of a few decades where we need to try to figure out how to get the data off. And you can use adapters. You can have old equipment around to some degree. It's not practical to have every piece of computer equipment in the history of computers, right? But a few things like a zip drive, a floppy drive, and adapters for them addresses a lot, because many institutions, when they do the inventory of what is in their collections, a lot of it is optical media, so either CDs or DVDs, and then a certain percentage is 3.5 or 5.25 inch floppy disks, and then so this is another example of the long tail, right? There's a very long tail of many other kinds of media, but dealing with those more common older ones is not impossible. It's just a matter of having the right equipment and expertise to do it, right? But I mean, your larger issue of how do we deal with obsolescence, right, which is obviously a huge and important one, is what occupies a lot of the digital preservation field in general, right? Because all of those levels I talked about can have obsolescence associated with them, right? Maybe you can read the disk, but you can't read the file system. So you can get the bits off the disk, but you have no idea where any of the files or folders are, right? Or you can read the file system, but you don't have an application that can actually open that file and render it, right? So that points to us where we have to solve the challenges, but it also can open up the possibility that if you realize, okay, at that third level, I don't have any software anymore, but I can operate at the 5th level, maybe you can still recover the information because you know that there are different ways that you can interact with the information.
Mais a question more? Yeah, all right.
Hi, Adrian from the Science Museum. I'm fascinated by the huge variety of different software tools you've developed through your various projects. Do you monitor the use of the different products that you offer, and ever feel what is the most successful of those products? And what are the gaps in digital curation and preservation?
Yeah, absolutely. It's a great question, and we don't have a incredibly systematic way because it's open source software and we want the barrier to entry to be as low as possible, so we don't require people to register to use the software. And we can indicate indirect measures like how many times it's been downloaded. We have, I'm trying to remember how many hundred Twitter followers we have. You know, there's certain ways we can measure the size of the community. It's certainly in the high hundreds of institutions I know are using the software. The consortium, so the ones that actually pay into this consortium so that they can help perpetuate the software, are a small set of them because anybody can use the software, but if you want to make sure that it stays alive into the future, becoming a consortium member can be useful. That's 43 institutions, right? So at least we know they're using it. I would say the BitCurator environment, which was that Linux platform I talked about, has been the most widely adopted and so successful in that way. A lot of the other things, I mean, the Raytom software is very new. We just started that project this year. Some of the things like BitCurator Access and BitCurator NLP, they have been adopted, but not as widely, and part of it is because it requires more investment of the institution to put things on servers and make technical decisions about how it's going to be administered. The nice thing about the BitCurator environment is it's basically a toolbox that anybody who can bring up a virtual machine, which, you know, might sound very complicated, but basically you download VirtualBox and then you can run this. They can just run it on their desktop, and they can take one of these workshops that we offer for a day or 2 days or 3 days or whatever it might be, right? And then they're up and running, whereas a lot of the other software requires a lot more conversation within the institution to say, okay, where is this going to go on a server? How's it going to be administered? How is it going to talk to other software that we have in our institution? So those have also been adopted, but not as widely as the BitCurator environment, right? So yeah, the gaps, I think, so I've talked about just a couple instances in which we're using natural language processing and machine learning. I think that's where a lot of the gaps are now, is between what we know in other sectors is being done very successfully and what's actually being applied in GLAM settings, right? So how can we take advantage of, say, machine learning to be able to categorize information, review things for sensitivity? It doesn't replace the human by any means. It supplements and supports the human so that they can focus their limited time and attention to the sort of judgment instead of just tediously looking through files. So I think that's where a lot of the sort of the gaps are in my mind, is you just see things that are being done, I'll say, in, you know, corporate environments, and you think, wow, that would be really great if libraries, archives, and museums would be able to use those things, right? And because the resources are very limited for GLAM institutions usually, right? And so that's been our primary motivation, is free and open source software, and to the degree possible, if we identify robust software that's already out there, we're not going to try to invent it, we're going to incorporate it and make it available for this audience, right? If we had tried to build this whole stack of software from scratch, it would have cost us, you know, $50 million and, you know, 20 years or whatever. I mean, there wouldn't have been practical. So I think it's sort of the bridging between what we know is already out there in other software to the environments that we work in is probably what I would say.
Infelizmente não temos mais tempo para perguntas. Agradecemos então a presença do Sr. Cole Lee, obrigado pela participação.